Question 17, or question 11 for extension students, asks you to explain how each one is a transformation of the first graph. So if I have question 17a ask me about y equals 2x, and that's essentially a straight line, goes through the origin with a gradient of 2, which means, yeah, it's going to cut through like that. So that's y equals 2x. Now, this one, y equals 2x plus 4, has gone up 4 spots. So instead of going through the origin, we're going to start from there. But essentially, it's got the same gradient, same everything. It's just being moved up 4 spots. Y equals 2x plus 4. And then if I'm going to do y equals 2x take 4, it's gone down 4. So this time it's going to be running, and I'm just trying to get a gradient of 2 going on. So it's going to look like that. So they all have the same gradient, they just have different y-intercepts. Question B is from x squared. So B, if I just do my generic formula, so x squared goes through like that, and this one should have gone further up like that. So that's y equals x squared. Now, the first one has gone up 9. The second one has gone down 9. The third one has gone right 3. Okay, so I'm going to give myself a little more space here, because everything's, 9, 9. I'm going to make sure my graph goes up to at least 9. And down to at least minus 9. And this one, so y equals x squared should go like that. Oh, sorry. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Should go like that. Okay, so that's just y equals x squared. Now, y equals x squared plus 9 is the same graph. It's just been moved up 9 spots. So it's, starting to go up from here. Y equals x squared take 9, which I think I was doing in purple. Yep. So this one is y equals x squared plus 9. Y equals x squared take 9. Same graph, but we're starting from down here this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this time it's kind of going up that way. And we also had a y equals x take 3 all squared, which means it's just moved right 3 spot. Looks like that. Okay, now minus x squared. I'll do this first one in light blue. So y equals 1 take x squared is the same as negative x squared plus 1. But let's actually start off with our y equals x squared. So 12c, 17c. Give myself a nice little axis. Y, x. And y equals minus x squared is going to go like that. it's a sad face. So then if I have y equals minus x squared plus 1, well, that's the same. Everything's just been moved up one spot. And then the next one we had was y equals negative outside of x take 1 all squared. So that's been moved left 1. So it's the same equation. It's just, you know, like that instead. I'll give myself enough space to write that. Y equals negative x plus 1 squared. And then the final question asks us negative x plus 1 squared plus 2. So that's left 1 up 2. Which means I now have something kind of going like that. Okay, 17d square root of x. Now this one has been moved left, left 4. This one's moved left 4, sorry. This one's moved up 4, and this one's moved left 4 down 2. So if I have 17d, none of these have to be amazing. Yx. So my normal y equals root x. It's going to look like that. My y equals root x plus 4 is going to look like that. My y equals root x plus 4 is going to look like that. And I think the last one was y equals root x plus 4 take 2. Root x plus 4 take 2. It's going to go like that. Okay, and that's 17d. Let's have a look at 17e, and that is y equals 2 on x. So just give myself a fairly normal looking axis. X and y. 2 on x is going to have the same intercepts, it's just a bit further from the graph than we're used to. Let's have a look at the transformations. The first one is up 1. The second one is left 2. The third one is left 2 and up 1. So, first one was up 1, yeah? So, this time my asymptote is across there. So this time a bit further from there and a bit further up there. Second one is 1 on x plus 2, so that's left 2 spots. So this time I'm kind of like there and there. And together, well, you kind of probably guessed it. It's that green one. Left 2 and up 1. Yeah, that's it. Like, you get a lot of stuff happening at once, but once you understand how to move them up, down, left, right, it's fairly simple.